Today, class, we're going to be teaching probability. And so, basically, we'll talk... Taylor, are you serious right now? You're making such a commotion. I can barely think.
Okay, I'm sorry, I just don't understand probability.
Taylor, what is there to not understand? Let's put it
the
this
whole
way.
concept.
Let's put it this way. Let me do an example for you. For instance, let's use your Chex Mix bag there. Alright? So, let's say that your Chex Mix bag has 20 M&Ms. And we'll say it's got 30 nuts. And then it's got 10 raisins. I don't know if I spelled raisins right. And 20 sunflower seeds. Probability is the likelihood that an event will occur, okay? So if you total these up, so let's see, you got 40, 50, 80. So that totals out to be 80. All right. So out of your bag, I'll stand this side, there's 1/4 of it is M&Ms. 3/8 are nuts. 1/8 are raisins. And another 1/4 is sunflower seeds. So, the probability of getting nuts over any other ingredients is greater because there's more of a likelihood of getting it because there's more
So that's
nuts.
why I haven't been getting the M&Ms that much. It all makes sense now. Thank you so much.
You don't need M&Ms anyways, Taylor. You're getting kind of chunky. All right, I'm gonna bet on 10. Don't have to get that close. Ooh.
That's close.
The reason it took me so long to roll a 10 was because the probability of rolling a 10 is 3 out of 36, or 1 out of 12.
Probability in blackjack. Let's go. Let's go.
Jed got dealt a 10 and an 8, giving him 18. Let's see what he does next. Jed now gets dealt a 2, giving him 20. He should probably stop now, seeing that he doesn't want to bust and go over 21. Let's see what he does.
Bust. You win. I win. Okay, cut it.
Jed ends up winning the game with 20 because the dealer busted. Now Jed asking for another card when he had 18 was a risk because the probability of busting was high. However, asking for another card with 20 is a very high risk because there are many cards that could make him bust.
Hi, I'm Taylor.
And I'm Amanda.
And here we are going to be talking to you today about probability using factorials, combination, and permutations.
This is called a factorial. It's not like an exclamation mark like you think. And all this means is that it's 5 times 4 times 3 times 2 times 1.
Okay, in the situation you'd use this, like, let's say you wanted to know how many different ways you could put 5 books on a shelf. So, I mean, this represents, I don't know, end it.
Action.
This represents the first 5 ways, or like, one of the 5 ways that you can... After that arrangement, you have one less arrangement that you can do. Since there are only 5 books, so you'll have 4 ways that you can arrange it, then 3, then 2, then 1, and so on. So that is factorials. Next, we have permutations, and the equation for permutations is permutation equals n factorial, which is n equals the number of possible choices and r equals objects that can be selected. N, or over n minus r factorial. And a situation you will use this is like how many ways the president and vice president can be chosen from a group of 7 people. And order does matter in permutations. Obviously, if you choose someone, the vice president and president are in different positions, so...
No, really?
I can't... I can't do this! I don't know. How do you describe that?
I don't know what I'm going to say about mine.
Are you filming this?
Finish it.
And then this is combination, and the only thing that's different is that the order.
Well, we didn't finish the vice president thing.
All right, permutations, combinations.
There you have it.
Wait, say what that last one is again.
Permutation and combination.
What's the difference?
The
Order does not matter in this
The
one.
order matters, doesn't matter, okay? All right, you got it.
So what's the whole thing with the vice president and the president?
Shut up. That's what the paper says.
So is there any kind of closing statement, or that's just what is
So
it?
have
We
a nice
slaughtered
day.
this. Hi, Amanda and I are going to be explaining to you guys when to multiply and add probabilities. How you know when to add probabilities is when the word or is used in a statement. For example, what is the probability of getting a 3 or 8th diamond? Right there. So here's I set it up so you guys can get a visual. There are 4 3s in each original deck of cards. So I put 4 out of 52 cards in the deck. And then I added, because of the or, 13 because there's 13 of diamond cards in a deck out of 52. And then you add them up. And since you have a common denominator, you're able to, and you just bring the 52 over. So your answer will be 17 over 52.
Now, I will tell you when to multiply. When you multiply, if you read this, there's a keyword and. And means multiply. So this says you want to find out black card and a 10. So there are 52 cards, and there are 26 black. And then this is you can multiply, and there are 4 10s. And there's your answer.
That's reduced, by the way. But
That's reduced.
okay, that is how you know when to add and multiply probabilities.